Morning to all. Today we are going to discuss about the limit, continuity, differentiability. Okay, what is the definition of the limit? A function f of z be any complex function. A function f of z is said to tend to limit L as z approaches z naught. If every epsilon greater than 0, there exists some small value delta greater than 0 such that modulus f of z minus L less than epsilon for 0 less than z minus z naught less than delta. Okay, that means a function f of z tends to L. F of z value approaches to L as z tends to z naught. As z approaches to z naught, the function value tends to some value. We are taking that value is L. This L is called the limit of the function. Symbolically, we can write it as limit z tends to z naught, f of z equal to L. L is said to be limit of the function at z equal to z naught. If you find the limit, always limit of the function is unique. That means if you use any of the path, always the limit must be same, unique. Continuity of f of z. So let f of z be any function. A function f of z is said to be continuous at z equal to z naught. If f of z naught is defined and limit z tends to z naught, f of z equal to f of z naught. That means these two conditions are satisfied. We are saying the function is said to be continuous at z equal to z naught. These two conditions are satisfied means what? First condition, f of z naught is defined. F of z naught is defined means we know function f of z. In this, substituting the point z equal to z naught, that value tends to finite value only. Then only we are saying f of z naught is defined. After that, check the limit value. Limit z tends to z naught, f of z value is equal to f of z naught. Okay, this condition satisfied means what? We need to calculate the limit value separately. That should be exist. That should be exist means what? That should be finite value, and limit must be exist means if you find any of the path, limit is unique. Then only we are saying limit is exist. And f of z naught value, we know comparing the both values, if the both are equal, then this condition is satisfied. If these two conditions are satisfied, the function is said to be continuous at the point z equal to z naught. Properties of a function, continuous function. Suppose the function is continuous at every point in a region. Suppose take the region, it has so many points. At every point case, the function is continuous. We can say the function is said to be continuous in that region. Okay, the function is continuous at every point in that region. We are saying the function is said to be continuous in the region. Take any two functions, f of z, g of z are any two continuous functions in a region. Then f of z plus g of z, f of z minus g of z, f of z into g of z, f of z by g of z, where g of z is not equal to 0, are all continuous. That means what? Take any two continuous functions. If you apply the addition of two continuous functions, subtraction of two continuous functions, multiplication of two continuous functions, and ratio of two continuous functions are all continuous only, but the ratio case denominator must be non-zero. If the denominator is 0, we get the infinite value. We cannot say about the continuous. Okay, two continuous functions, apply the addition, find the difference, multiplication, ratio, all are continuous. And every polynomial is continuous. If you consider the any polynomial or any algebraic expression, that will be continuous, and constant function is continuous. Suppose take the function f of z equal to k. Substituting any value of z, z equal to 1, 2, 3, I, 2i, 3i, every case the value is k only. So the type of the functions are constant functions. Constant functions are continuous. Suppose the function f of z is not continuous at z equal to z0. Then that point is called a point of discontinuity. The function is not continuous at z equal to z0. That point is called point of discontinuity. When it is possible, function is not continuous at z equal to z0. That means if the function is continuous means what? Two conditions are satisfied. One of the condition is function is defined. Other condition is this is equal. Any of the condition fail, we are saying the function is not continuous at that point. That point is called a point of discontinuity. Next, differentiability. Suppose f of z be a complex function. It is defined at a point z0. So the derivative of a f of z at z0 is denoted by the f dash z0 and defined as f dash of z0 equal to limit z tends to z0 f of z minus f of z0 by z minus z0. Okay. Limit value exists. This limit value exists. We are saying the function f of z is differentiable at z equal to z0. This is denoted by f dash of z0. Limit is exist. Limit is exist means what? Limit tends to finite value, and other version is if you find any path, limit should be unique. Then only we are saying limit is exist. If this limit is exist, the function f of z is said to be differentiable at z equal to z0. Next. Suppose the function is differentiable at z0, then f of z is continuous at z0. Every differentiable function is continuous. Suppose one of the function is continuous, automatically we can say that function is also continuous. Let us see the problem. Suppose the function f of x comma y is given x cube minus y cube by x cube plus y cube, defined if x comma y is not equal to 0 comma 0. 0, x comma y is equal to 0 comma 0. So discuss the continuity of f of x comma y at the origin. So we need to find the continuity. Discuss the continuity of the function at the origin. So the given function is defined in the two cases. One is equal to 0 comma 0 case, other one is not equal to 0 comma 0 case. Let us take the function f of x comma y equal to x cube minus y cube by x cube plus y cube, and equal to 0 case 0. Equal to 0 means what? In place of x comma y, take 0 and 0. That means f of 0 comma 0 is 0. So for continuity case, first we need to find the limit value. So check the limit value. Limit x comma y tends to 0 comma 0 f of x comma y. We need to find this limit value. Check is this exist or not. So x comma y tends to 0. Observe the xy plane, x-axis, y-axis. So x comma y point, this is we are taking as a P. O is the origin. So x comma y tends to 0 comma y means what? P approaches to origin 0. P approaches to O. How can you approaches P value to O? We have the different ways. One of the ways, move P to some other point on the x-axis, M to O. P, M, O, one way. Other way is P to N on the y-axis, Y to O. So P, N, O. Other way is direct, P to O. Other way is curve path. P, O, lower path and upper path. We have the so many paths. Why? Because we are discussing about the complex numbers. So in XY plane, we can approach the given value to the limit value in any of the path only. But the real number system, we have only two ways, that is left hand and right hand. But the complex number system case, we have the so many paths. So we need to find along all the paths limit is equal. We can say limit is exist. So first find the path PMO along PMO. PMO means what? P to M. Observe the coordinate. X coordinate as it is, only y coordinate becomes 0. So first we need to substitute y tends to 0. Next, x comma o, p to m, next m to o, x comma o to x comma 0 to 0 comma 0, x value tends to 0. So first in PMO case, we need to substitute y tends to 0, next x tends to 0. Let us take the limit x comma y tends to 0 comma 0, f of x comma y. Here first we want to apply y tends to 0. So this is y tends to 0 of the function. Before we have x tends to 0. Okay, inner part is first, outer part is the next. So y tends to 0, y value 0, x cube by x cube, that is 1. So limit value is 1 along PMO. Next along PNO. PNO. P is x comma y, n is 0 comma y. So here x value 0, x tends to 0, y value as it is. That means first we need to substitute x tends to 0. After that we need to substitute y tends to 0. Take the limit value, limit f of x comma y, x y comma y tends to 0 comma 0. First we are applying x tends to 0. So inner part is x tends to 0, outer part is y tends to 0. Substituting x equal to 0, x value is 0 minus y cube by y cube. That means minus 1. There is no y value, so no need to apply the limit, that is minus 1. Comparing first these two paths. These two paths are equal, go to the next path. But these two are not equal. That means what? Limit is not unique. Limit not unique means what? Limit doesn't exist. Limit doesn't exist means what? Continuous fails. So the given function is not continuous at this point, 0 comma 0 case.